Hello dear students, in this lecture we will try to understand what molecular projections are. This is an essential topic as far as enantiomerism is concerned. So before talking about enantiomerism, we must be acquainted with different molecular projections of a molecule. So molecular projections is actually the representation or manifestation of a molecule. For example, we have two structures over here. The first one is a 3D projection or representation of a molecule, while as the second one, that is the cross lining, which are perpendicular to each other, is a 2D way of representing a molecule. Now, how many ways we can represent this molecule? We have following types. Number one is wedge dash projection or formula. This is a 3D representation of a molecule. In this representation or in this projection, tetrahedral carbon atom or any atom has got 4 bonds. Among them, 2 bonds lie in the plane of paper, which are shown as bold lines. One bond is facing the viewer, that is shown by wedge, while as the other bond is away from the viewer, that is shown as a dotted line. For example, we have this molecule. In this, carbon atom is attached to 4 different groups. One is hydrogen, chlorine, fluorine and methyl group. Hydrogen and chlorine are connected to the carbon by means of bold lines, indicating that these are the bonds which lie in the plane of paper. Wedge bond, which is attached to methyl group, is facing the viewer, while as dotted bond attached to fluorine is away from the viewer. This kind of representation of a molecule is called as wedge dash projection or wedge dash formula. I hope you understand it. Now we have the next type, that is the Fischer projection. Fischer projection is actually a 2D representation of a molecule. In this projection or in this representation, tetrahedral atom is shown by 2 intersecting perpendicular lines, and atoms or groups are attached to these intersecting lines. For example, we have this molecule in which we have 4 groups attached to it. That's methyl, chlorine, fluorine and hydrogen. The cross center is basically a tetrahedral atom which is shown by 2 perpendicular lines, and this kind of representation is actually called as Fischer projection. Now, this Fischer projection is usually obtained from 3D representation by means of the fact that in 3D projection, atoms or groups which are facing the viewer, that is 1 and 2 over here, are shown horizontally in Fischer projection, while as atoms or groups which are facing away from the viewer, that is 3 and 4 here, they are shown vertically in Fischer projection. And one point you must understand is that the carbon chain is usually drawn vertically with the oxidizer group, with the most oxidizer group at the top. For example, talking about mesotartaric acid, which is having a plane of symmetry, in this is a Fischer projection of representing the molecule, and carbon chain is shown vertically. Now, in addition to these projections, we have 2 more. So we have one Sawhorse projection. In this projection, carbon-carbon single bond is shown as slanted line, and atoms or groups are connected to these carbons, which may be in staggered or in eclipsed conformation. For example, we have this molecule there. Left carbon is facing the viewer, while as the right carbon is away from the viewer. This kind of representation is known as Sawhorse projection. And next is Newman's projection. In this projection, carbon-carbon bond axis is towards the Weber. Front carbon is shown by 3 intersecting lines, while as rear or back carbon is shown by circle to which atoms or groups are attached, and these atoms or groups may be in staggered or in eclipsed conformation. These two representations are usually discussed once we talk of conformation or conformations. We shall be talking about that conformation hopefully later on. These are basically the 4 representations of showing a molecule. One was a wedge dash notation, the next is a Fischer projection, third Sawhorse projection, and the fourth one, that is the Newman projection. Sawhorse and Newmans are usually discussed in conformations, while as we are having wedge dash and Fischer, they have got a huge importance as far as RS system of nomenclature is concerned, which carry meaning once we talk of enantiomerism. I hope you understand it. In the next video, hopefully, we shall be talking about how can we convert wedge dash formula into a Fischer projection and vice versa. And then we shall be discussing RS nomenclature. Till then, take good care of yourselves and do not forget to subscribe my channel, like my videos, share it. Thanks for watching DHC.